Okay, so I'm going to go through this. Trig functions for any angle. So the way that this works now is what we have to worry about is that trig functions are now going to, the triangles are now going to go to the coordinate plane, okay? And so now what we have to do is not worry about like what the sine, cosine, tangent, cotangent, cosecant are exactly. We want a further elaboration. We want to know its orientation on the coordinate plane, all right? And by knowing its whether or not it's negative or positive, we can know exactly what quadrant it's in so that we can figure out exactly how the triangle is actually laying, like how it's angled, okay? And so we're not just going to be drawing generic triangles to model a situation. We kind of want to know whether or not something is in the first, we really want to know if something is in the first, second, third, or fourth quadrant, all right? So one of the things that's going to have to happen then is we're going to have like, we're going to have to kind of like figure out when we have a point, like what kind of triangle, like what angle am I from the origin, okay? All right, so one of the things that we're going to do is we're going to be using the Pythagorean theorem again, okay? You can see here that if my angle is theta here, my r is kind of the radius. If this guy were to spin around in a circle, that would be the radius. And so that's actually why we use an r. We've been using h for hypotenuse for a long time, but now it's going to be r because we want to kind of imagine this kind of spinning amongst the four quadrants. Now if I have the actual coordinate, what I have is I actually have the sides of this triangle, okay? So this allows me then to say that if I have an x and y coordinate, then I actually can find out how far away I am from the origin, okay? So if I have a frame of reference, a point that I want to locate like on a map, and then I draw out to here, if I know its latitude and longitude, I can figure out the distance from that origin, okay? As long as I know its latitude and longitude. All right, so anyways, how this would look like is we've got a squared plus x squared plus y squared equaling r squared. Okay, so it is just the Pythagorean theorem. Now then, the sign is no longer going to be like O over H. What we want to do is we want to convert that to the coordinate plane now. Okay, that's why I'm making a video for this, because it's not a big jump. It's not very hard to grasp. And so what we want to do is we now want to consider this as a as the O, the new O, over the new H. Okay, so it's going to be the y coordinate over how far you are from the origin. All right, now cosine is going to follow suit, but he's going to be the x coordinate over r, because you can see here that this would be the adjacent side to this angle. Okay, tangent is going to be the same thing. It's going to be y over x. Cosecant would actually just be the r over y, because remember cosecant and sine are just reciprocals of each other. And likewise with this. Okay, and then cotangent would be x over y. All right. Okay, so how do we apply this then? What we're going to do now is we're going to see that some of these will now be negative, because is that all right? If it's negative, like if x is negative, then the ratio will be negative. If y is negative, then the ratio could be negative. If both are negative, then the ratio would be positive. So it all depends on the situation. So let's look at this here. All right. We want to look at 9, negative 12. Now let's figure out where we are on the coordinate plane. All right. And that's 9. Okay, so we're 9 over here, and then we're down negative 12. So we're right here. Okay. All right, so that's where we're at. All right, and this right here kind of represent, like this is actually a triangle now. All right. And we want to be able to find all the exact values of this situation. Okay, we have 9, negative 12, and I can get all 6 of them just by drawing this out. Okay. Now, first of all, I need to know the r value, right? So this would just be x squared plus y squared equals r squared. So that would be, excuse me, 9 squared plus, notice that I'm putting the negative 12 in parentheses, r squared. That's going to be 81 plus 144 r squared. That is 225 r squared. And so now if I took the square root of that, I believe it's 15. Okay, so now what that does is it tells us that this guy, let me change colors here, this guy is actually 9, this guy's 12, but he's negative, okay, and this guy is 15. Okay, and so now that I have this new triangle, notice that the difference is that the y value is now negative because of our orientation in a particular quadrant. Okay, so far everything we've done is basically has been in the first quadrant. Okay, and so now what we've got is we have the sine is actually negative 12. Okay, remember this is our theta. Okay, so we can look from here. Actually, no. Actually, what we want to do is we want to look from here. Okay, which makes it even kind of stranger. But all the way from here, it looks like we've got negative 12 over 15, which can reduce to negative 3 will go into both 4 over 5. Okay? All right, but notice that the sine is now negative. All right, what about cosine? That was 9 over 15. All right, well, 9 over 15 reduces to 3 over 5. Okay, so that's actually positive here. The tangent is just the O over H, which now is the y over x. Our y coordinate is negative 12 over 5, and that reduces down to negative, not 5, it's, x coordinate is 9. Okay, 3 goes into both, that's negative 4 over 3. Okay, notice that tangent is negative. That wasn't the case before, they were always positive. Okay, flipping this guy around, if he's negative, he will stay negative. Okay, if he's positive, he will stay positive. And if he is negative, again, he will stay negative. All right, that is all settled. That's good to go. Well, what do you keep dropping, Atticus? What is it? Hot dog. All right, this guy. Negative 6, so negative 6, and then we're going down negative 2. So we are over here, and our triangle looks like this. Okay, but we're basically focused on this little piece here. Okay, so now let's figure out what our hypotenuse is, because again our goal here is to find all 6. Our hypotenuse is going to be our negative 6 squared plus negative 2 squared equals r squared, that's 36, plus 4, r squared, that's 40, r squared, square root of 40. Alright, and I can take a 4 times 10, that's 2 can come out, and then I'm left with a radical 10. Alright, so that's the radius. So now what I want to do is, since I have the x value at negative 6, I have my y value at negative 2, and I have my r value at 2 radical 10, I can just use these three. In fact, you could just label them before you even get started here, and then you can just carefully execute their ratios, okay? But notice that, excuse me, notice though that I do have a couple negatives, and we'll just kind of see how that plays out when I figure out the things here. Okay, so for sine, what I get is I get y over r. So y over r is negative 2 over 2 radical 10, which is, looks like the 2's cancel out, so that's negative 1 over radical 10. Remember, I'm going to multiply both the top and the bottom by radical 10, and that gives me radical 10 over 10, but he's still going to be negative. Okay, so that is the sine of theta for this point. Okay, cosine is going to be the x value of negative 6 over 2 radical 10, and that will give us negative 3 over radical 10. Multiply both the top and the bottom by radical 10, and you get negative 3 radical 10 over 10. And you just leave it. Okay. Now there is a side step. Maybe you want to write that in, but I just don't have a lot of room to write. multiply by radical 10 on the top, radical 10 on the bottom. Tangent. Tangent is going to be y over x. Y over x is negative 2 over negative 6. Alright, so notice how the sine and cosine stay negative. This guy actually is going to become positive 1/3. Okay, so tangent is positive over here because both your sine and cosine are negative. Alright, now there is a pattern to this actually, but we'll address that in a few. Cosecant would be this guy flipped over, so 2 radical 10 over negative 2, which just gives us negative radical 10 because the 2's cancel out. Secant would be this guy. We don't have to do this, we could just look at him. It's going to be a negative radical 10 over 3. And then this guy would just, reciprocal of 1 over 3 is just 3. Okay? Again, they're both negative, so the tangent and the cotangent becomes positive. Okay, so moving forward then, what you probably might see is that there are certain quadrants where the sine is going to be negative and where in certain quadrants it'll be positive. Okay, so it all depends on where you're at. And so we want to use this, there's actually a mnemonic called all students take calculus, which is definitely not true. But all students take calculus means that if you go from quadrant 1, 2, 3, 4, what it means is that if you know which quadrants the trig functions are positive, okay, you'll know when they're negative as well. Okay, so this will tell you where they are positive. Okay, in quadrant 1, if your point is in quadrant 1, then all of your trig ratios will be positive, and that's what we saw when we do our realistic kind of applications, right? But as soon as we start moving to other quadrants, those values take on a different thing, okay? Namely, when we get to quadrant 2, okay, over here, notice that as soon as this is quadrant 1, 2, 3, and 4, okay, remember it goes counterclockwise. As soon as we go over here, this is when the x values start to get negative, okay? And so what this means then is that cosine becomes negative. Okay, cosine becomes negative because remember, he is related to the x value. Okay, so when that happens then, he is going to become negative, but sine is still positive. Sine is the y value. It's related to the y value. So that means that sine is going to be positive there. So in quadrant 2, sine is going to be positive. Okay, so all students, alright, when you come here, here is where both sine and cosine are negative. Okay, but because both are negative, okay, when you look here, if both are negative, tangent ends up being the positive one. Okay, and I'm going to stop right after here because I see my time here. And then, so this guy's tangent. And then over here, we go back to the x-coordinate being positive, but then the sine is negative. So therefore, it is cosine that is positive there. Okay, now with that, if sine is positive, then cosecant is definitely positive. If tangent is positive, so is cotangent. Okay, and if cosine is positive, then secant is positive. Okay, so all students take calculus, and that's how you remember when things have to be positive. All right, we'll continue this in the next one.